Professor Wergely's here. Today we're on lecture 26. We're going to go over Firestore, and hopefully we can get into cloud functions. For the final project, what would be nice is if you could link your entire project with Firebase. Doesn't have to be. You can use Node, MongoDB. You can use PHP, MySQL. But if you link it all in the Firebase dashboard, they have a lot of nice tools that we talked about before. So we looked at authentication. We got a little bit involved with Firestore. When a user signs up, we then set their user information here in the Firestore. I looked, and it looked like information was not coming in. And when I clicked on this today, there was a little message up here at the top, and you may see this if you go to your Firebase console. There's a little message up at the top that says get started. And it looks like before data can come up, you must pick the region that your Firestore database is going to be set up in. So up at the top, it's like a bright orange message, and then it has a Get Started button somewhere towards the left. If you click that Get Started button, it'll ask you what region. It'll default to US Central. I recommend to go ahead and use US Central. And then it gives you a warning. It says the region cannot be changed later. Go ahead and click OK. And then once you create a new user, you should see that information coming up. For example, we've created 4 test users already, but you'll see only 2 of those test users came up because I just now recently clicked the Get Started button. So make sure you do that. That way you can see the data coming up. Otherwise, we're not going to be able to use Firestore. Now, here's how the structure is going to go. So there's going to be each user, and I made the database structure really simple. If you look at my other app, the Problem Solver, the database structure is actually fairly complicated. We can take a look at that here in a little bit. But all I want to do is there's each separate user, and each user will keep track of what class or what professor they want to calculate the GPAs. So remember, we're using the Mizzou grade distribution. So if I do Mizzou grade distribution, they have this music 1. Okay, we're using this site to pull in all our data. We're using these professors here. And essentially, we're going to rebuild the site where we're going to stream this data ourselves. We're going to show the professors as well, except we're going to also show graphs. Okay, we're also going to show graphs. So essentially, each user that logs in will be able to keep track of which professors they select. So they'll select some professors, let's say Professor Wergely's, and then that user will be able to keep track of Professor Wergely's. Now, we don't want to store the data twice. So we're going to make a way where each professor is stored once, and all the users use that information. So if I go back to Firebase, I'll have a user here. This user will have a professors array, and then I'll have a professors collection that will keep track of the professors only once. Okay, that way I don't have duplicated data. And that's kind of the structure of our Firestore. Okay, so if you do not have Firestore, if you don't see what I'm seeing, go ahead and click the Get Started button, and then you can run the app. So if I go to this link, Lecture 26's link, let's go ahead and clone the repo. There's a lot of new code here, so let's start from the new code. Open up VS Code, open up a terminal. Okay, we're in Lecture 26. So you can go into your lectures directory. I'm going to go ahead and make a new one called Lecture 26. It's Firestore and Cloud Functions. Okay, Firestore and Cloud Functions. CD into Lecture 26. And then I'm going to do a git clone. Go ahead and clone the new repo. It's the same as before. And actually, you could go back into Lecture 25 if you want and just do a git pull. You could do a git pull dashboard during class. That would also work. I'm going to go ahead and clone the repo, put it in another directory. Probably shouldn't do this. Otherwise, we're not really taking advantage of Git. Okay, you'll see here if I do a git status, once I do a clone, I'm in the master branch. So I'm going to do a git checkout to the during class, dashboard dash during class. Okay, so now I have this code here. I have a bad feeling about setting these projects up this way. I'm going to bounce out. Let's not do this. Let's not do this. Let's use git. I'm going to go back into lecture 25. Yeah, otherwise we're going to have to install the node modules again. It's going to take up twice as much space. There's no reason to clone the repo again. Let's use git. I'm going to cd integrate distribution. This is lecture 25. If I do a git branch -a, you'll see I have Firebase login before class and during class. All you need to do from the previous lecture is do a git pull origin, and then do dashboard dash during class. This is probably better. That way I don't have to reinstall all the node modules. All I'm doing is taking the differences. I'm just taking the differences and downloading them, and I can run the project from last time. If we start all the way over, we got to reinstall all the node modules, and it's going to take some space and take some time. So this is probably the better way to do it. If you weren't with us during last class, you will have to do a clone. You'll do a git clone, npm install, and then you can run the project. If you were with us last class, you don't need to worry about that. Just cd back into lecture 25 and then do a git clone, git pull. Let's see, if we're copying a new git repo, will we need to link this to Firebase as well? If we did the clone, we would. Okay, if we did the clone, we'd have to redo all the Firebase stuff. I put the Firebase environment variable, and I just took out my credentials. So you can put your credentials in here. We'll probably do that first. Let's see. Sweeta says you can put the config info in the environment's TypeScript. Ian says I missed the first 10 minutes. What did we miss? All we did was we did a git pull. Okay, we did a git pull dashboard dash during class. Okay, we're going to do a git pull dashboard dash during class, and then we're going to cd into that. Or not cd, I guess we're going to do a git checkout, then do a dashboard dash during class. Okay, so I switched. Once you switch, let me open this up. I'm in the wrong one. Let me just open up a new window. Okay, let me open this up. So I'm in lecture 25. We decided not to clone the repo again unless you were not here last time. We did a git pull dashboard during class. You'll see the environment variable is empty here. I took out my credentials, so you'll need to put your credentials in. So what you'll do is go to your Firebase console. Okay, go to your Firebase console. Go over here to settings up here at the top. Go to project settings and then grab the configuration. So grab the API key, app ID, all of the information between the brackets, and then paste it right here into Firebase. Okay, paste it right here into Firebase. Some students, I put grade distribution app fall 20. Some students were having problems because this app had already been, the name had already been created. Grade distribution app is also created. So some students were doing grade distribution app and then their paw print. And then they put their paw print here, which allowed them to create the app on Firebase's console. Put your Firebase information, and let's check out what we have. So we've added quite a few things. So one, we have a lot of more types. Instead of just user information, we have professor information. Okay, we have professor information. We also have class data. Class data is actually from the website. So if I go back to this website here, you'll see I searched. You'll see I have course department, course title, course number, section number, term, course, instructor, A, B, C, D, F range, and then the average grade. So this is the information I'm going to scrape once I get there. So you'll see the information that I want to store. Instructor, number, section, term, title, department, A, B, C, D, F, average, updated at, instructor ID, and then UID, which is going to be your Firebase ID here. And you'll see I also have add professor data response. Just basically when were the classes added and how many classes have been added. Okay, I've added a new service file, quite a few. Okay, you'll see our auth services are still there, but I also added a data service. I also added a card resize service. This is just for UI. We're going to talk about this here in a little bit. In the pages, you'll see I have added one additional page, which is the dashboard. We're going to be working on the dashboard today. And I actually added some components as well. One of them being a nav bar. You should do this with your nav bar. Don't put the nav bar on every page. Don't put it over here in your app component. I see a lot of students put a nav bar up here. Don't put the nav bar up here. Now you can put the nav bar HTML element, but don't write the code in here. Go ahead and make a nice component for your nav bar and separate it out. Okay, we haven't written it yet. We're going to try to get to that today. In addition, this add professor component is a mat dialog. So let's say I want to show this dialog on the UI. I don't want to have to write this code in every page. I can create a component. And then over here in the TypeScript, you'll see I have an app add professor selector. So every time I use this app add professor selector, whatever component I created here will be displayed. Okay, and you'll see that here in the dashboard. So if I go to dashboard HTML, okay, you'll see I have my app nav bar. I don't have it set up yet, but we will. You'll see I have a div. I'm using the flex layout. Okay, flex layout. You'll see an app module. I've imported this already for you. It's called the flex layout module. Looks like we have some errors here. We may need to download it. Okay, we may need to do an npm install. But I'm using the flex layout. I have a mat grid. Basically, I have a card. It's going to ask them which professor they want to use. And basically, when they click the button, I'm going to go ahead and try to add that professor to that user. Okay, I'm going to try to add that professor to that user. So let's start with fixing this up. So it looks like an app module, we need some imports here. So what you can do, make sure you're in the dashboard during class, and then do an npm install. npm install, there may be some packages that we're missing in our node modules from last time. Okay, you'll notice how many imports we have. We got a lot of imports here. We're using a lot of Angular material. We're using reactive forms, which is a requirement for the final project. All of our components. So this app module will get fairly large. Okay, do an npm install. Make sure you get your flex layout. Okay, you'll see I do not have that error anymore. It's adding some other imports as well. Now, you'll want to, if you want to use some of the things that I'm using, you want to go and look at the web. So if I come over here to the web and I just search Angular material, flex layout, I don't know if you remember Flexbox and all of that from 2830. We talked about it. You'll see here's the Angular flex layout. It tells you if you want to install it, go ahead and run this command. Now, I've ran this command already. It's already in the JSON file. But if you needed it, you could run it. You can see how to use it. You can see what kind of flex layout you want, either rows or columns, and then all of the properties. So we used Flexbox, and we changed the CSS. So we would say display flex, and then we would say row wrap, and other properties in CSS. With Angular, it's different. We're going to use these attributes here. So we're using these Angular attributes to define the Flexbox. And you'll see that here. So once this is successfully added, I go back to the dashboard, you see I'm using the flex, I'm using columns. Okay, so I'm going to have columns for each of my cards, basically. Now this can be achieved in several ways. Material has columns, Flexbox has columns. If you want them to be responsive, Flexbox is an easy way to implement it, but there's also other ways to implement it. So if you go back to the final project requirements, and they may be slightly modified on the rubric, but essentially what you see is the requirements. But if I come over here to the Hack Week project and scroll down, you'll see it's got to be persistent. It also needs to be responsive. Okay, responsive is one of the requirements, and that's why you'll see I'm using my flex layout here. So you want to research this a little bit. It's really easy to use. You'll see I basically just have a div and I call my flex box on it. Okay, you also see I have this card resize service. How many columns do I want to display? If I go over to this service file, you'll see I have a card resize service. All it is basically going to dynamically set the breakpoints. Okay, the breakpoints, you'll want to look at responsive page design, and that's going to be one of the first ones was Bootstrap. Okay, so if I look up Bootstrap breakpoints, and Material has their own, Ionic has their own, you can look at theirs, but here's some good breakpoints here. So you'll see these are the default breakpoints. So I have small devices, medium devices, large devices, and extra large devices. So you'll see it's 576 pixels and up. Okay, will be a small device. So usually extra small devices are lower. Usually you'll see one column. Maybe small devices also have one column, but they're a little bit larger. Medium devices may have 2 or 3 columns. Desktops may have 4 columns. Extra large devices may still have 4 columns, but you'll have some space on the side. You'll have some margin on the side. So these are similar breakpoints that we're using. You'll see there's 1, 2, 3, 4. If I come back over here, I also have 4, but I also put my extra large devices as 4. So all this is going to do is check the number of columns, and when the breakpoints are modified, it will return back the corresponding breakpoint. Okay, why this is useful is because on my display, you'll see this is determining the number of columns. So on my Mat grid list, the number of columns will be asynchronous. I've made my own service for that. And depending on the size of the display, will depend on how many columns I show. Okay, that's what I've implemented here. So let's get into some functionality. So when I log in, let's run this app. Let's see if this app will run. I put my Firebase credentials. And by the way, I fixed up the login page. It looked like I missed a few imports. Let's see, I may have an app running on another one. Let me close that. Let me try to run this again. I fixed up the login page. All of the code was correct. It looked like I missed a few. It looked like I missed a few imports here. I missed my Flex Layout module import. I missed my, I think I missed the grid list module as well. And there was a few others, tooltip module. A lot of these were missing. Once I added these modules in, my login page started working. And definitely try to use some of this code. So if you're going to go the Angular material route, go ahead and use some of the code. That's okay. Now you're going to see the code's going to crash. I don't know if you'll actually be able to see it until we write some of it out. Can you see the login? No, you cannot. Okay, we got to write some of this out. A lot of these functions are supposed to be here, but they're not showing up. So let's go into the dashboard HTML. Let's see what we have. So one, when the page loads, I want to know which professors to show in the cards. Okay, so you'll see I have a router link. When they click on the professor, it's going to go to a different page. You'll see I have an NG4 that links through all the professors. So let's go to the dashboard component TypeScript, and let's write out some of this functionality. Give me 1 second. Okay, here it is. So let me go to the dashboard page. Okay, so you'll see here I've added some imports. So I have a data service. That's going to be my model. I have a mat dialog. I still have my auth service. Every page you go to, you should check to make sure the user's logged in, which we're going to do in a second. And then I have my card resize service. So I've added the imports. You'll see I have professors, which is an observable array. This is what you need for Firebase. If you look at the docs, everything that returns back from Firebase is observable because it's using sockets. It's all real-time updated. So if I go back to the Angular Fire tutorial, so if I go to the Angular Fire, okay, it's the GitHub here. Make sure you're using this GitHub. If I go to the docs and go into Firestore, don't use the real-time database. Make sure you're using Firestore. And if I go, let's say, to collections or documents, you'll see I have an Angular Firestore collection. You'll see each of the items that are returned are observable. Okay, they're observable because the values will change. The values are going to be dynamic. When the values change in the database, the values will also change here on the front end. So each collection, each array has to be of type observable, and that's how you get it in from Firebase. And you'll see here the example has an ng4. It goes through items, and you have to put this upward slash and then the keyword async, because this is going to be asynchronous. Okay, this is a requirement if you want to use Firebase. Now, you can make it where you don't pull the real-time changes. Like I said, for Facebook, that may not be desirable. You're looking at a post, 10,000 posts come in. The post you were looking at now gets pushed down to the bottom. You try to look at the new post, and it gets pushed down to the bottom. You could never read a post. So Facebook will have real-time updates. It'll tell you, hey, some new posts have come in. Do you want to load them? And then the user has to click, yes, I want to load the new post. That way they have a good user experience. So in some cases, you may want to turn the real-time updates off. And they talk about how to do that here in this document. You don't have to use the async. You can just grab it as an array, and the values won't change until you grab it again. Okay, they have a good example here. But you'll see that's what we did here. So I have it as async. Professors is async, because that's going to be coming in from the database. Let's write some of this out. So first, let's say I want to add a professor. Okay, let's say I want to add a professor. I'm logging in for the first time, and I want to add a professor to keep track and follow them. So I'm going to create this method here, add professor. And I'm going to use my own component. You'll see I have an add professor component. It's basically a mat dialog. I'm going to use my own custom component here. So how do I use my own custom component? I'll say this dialog. You'll see I'm using a mat dialog here as the import. So I'll say this .dialog. I'm going to open one up, and the style is going to be my add professor component. I'm going to set some parameters, maybe set the width to 360 pixels. And I want to set the disable close to true. If the user wants to close it out, they can. Okay, so this is how you can add your own custom components into a dialog. Now you'll see I've already added the import up at the top. I've already written the code, but I'm adding this add professor component dynamically. It's my own custom one. We'll take a look at it here in a second. Another thing you may want to do from the dashboard is to be able to log out. So I'm going to have a log out button somewhere on the display. And basically, it's just going to call the auth service. Instead of writing the log out code in several spots, make sure you write a service file. So I have a service file for pulling the data. I also have a service file for authentication. I recommend you do the same. That way everything's kept nice and separated. And then instead of writing the code over and over again, I just keep calling the service file. And that's the way to do it correctly. And in addition, okay, when I pull the data from this website here, I'll come back to the code. You'll see it's not in a very good format. This is the actual data that we're going to pull. We're going to pull these professor names. It's in a horrible format. So what if I want to reformat this? What if I wanted to say first name and then last name? Or maybe first name, middle name, then last name. Okay, I can do that. So I've created a formatter. It's my own custom formatter. It can be modified. Okay, so I have one called format name in the front end. It takes in a string and it will return a string. And I'm going to be using this over and over again. I'm going to be using this over and over again. So I don't want to rewrite the code over and over again. So in my data service, I have a prettier. I have a prettified name that takes in a name. Okay, we can take a look at this function here in a little bit. So if you see yourself in your final project writing code over and over again, I need it on every single page. Don't put that in the components. Create a service file, even if it's a service file with just one function. That's okay. That way you don't have to keep writing this over and over again. Maybe I need to format the name or format the data over and over again. Only write the code once. That's going to go back into this category here. So if I go back to the Hack Week project, you'll see I have consistent design. That's going to be the UI design. I also have well structured. This is going to be your code. Your code should be well structured, not written over and over again, using service files. Okay, which is what we're doing here. Okay, at the beginning, we want to be able to get the professors to show it in this little mat card. So if you want something to load on once the page is first loaded, put it in the constructor or put it in the ng on init. Both of these will load once the page is finished loading. So once the page loads, you'll see I have a professors variable. And instead of calling it over and over again, writing the same code, I'm going to use the data service. I have a get professors method that we're going to take a look at here in a second. Okay, I have a get professors method. So once the page loads, this constructor will get invoked. It'll get called. And I'm going to load the professors from the data service. Okay, I'm going to load the professors from the data service. So the main thing here is just, separate your code out into the service files. If you remember in 3330 when we talked about MVC, the controller actually didn't have much code at all. The controller was the middleman. It handled button clicks and it grabbed and it manipulated data from the model. So it connected to the model. You'll see there's not much code here. I handle button clicks like add professor, or I get data from the model. Okay, that's how your code should be as well. The component files will be small, the service files will be large, and the HTML files will be large. So 3 functions here. They need to connect over to the data service. Let's fix up the data service. So I will show you how to connect to Firestore. We haven't done that yet. Right now we're just kind of doing MVC. Let's see how we can connect to Firestore. So go over to your data service.typescript. Okay, go over to your data service.typescript. So you'll see here, I've added a lot of imports already. You'll see when I want to get the professors, this is the method that we just called. First, make sure they're logged in. Before you get any data for the user, make sure they're logged in. And I actually do this on every page. So on the login, I see if they've logged in before. If they have, redirect them to the home page. On the home page, check to see if they're logged in. When they go to get some data, check to see if they're logged in. The more checks that you see if they're logged in, it would be better because your application will be more secure. There's also something called an auth guard. You probably looked at the auth guard in one of the challenges. We're going to implement an auth guard here shortly where they cannot URL hack the page. That's a requirement. We're going to be trying to URL hack your pages. Here's a security requirement. You should be using HTTPS, and your pages should not be able to be URL hacked. Basically, where you go up here and you bypass the login. Right now, I can do that. So if I go, well, I guess we can't see the page, but when we run it, it's on login. If I just rewrite this to homepage or dashboard, I'll go to the dashboard and I'll skip over the login. So you should not be able to URL hack your page. And the way to fix that is with an auth guard. So let's look at this get professors method. I left it here because there's a lot of code and it's complicated. So first, and actually this line could be taken out. I really don't need this line. I'm going to take this out. They actually changed the way that authentication works. In the old times, which old times is a year ago, in the old times, you can do the Angular Fire auth, then they'd have an auth keyword, and then you could do current user, and then you could grab the UID. They don't have that anymore. Now you have to grab the current user. Current user is actually an asynchronous function now. So all I used to be able to do UID here and grab the current user. I don't have that anymore. Now I have to do a then function, which you'll see down below. Once the current user is loaded, then I'll have the user information. Once I have the user information, then I can grab the UID. It's kind of complicated. They switched when they went to the new Angular. When they went to the new Angular Fire. It's been updated recently. So they will no longer have this code. Now, if you go to the documentation, so let's say I do Angular Fire, get current UID. Remember I told you to stay away from some of these websites here. So let's look at Stack Overflow. Stack Overflow actually talks a little bit about the new one, how you have to subscribe. Talks about here how it's subscribing, so that's similar to what we've done. Let me see if here's this Fireship. This is the one that a lot of students use. Looks like they're doing a promise as well. Looks like theirs is a little bit more complicated, but I'm trying to see if any of these are old. I wanted to show you the old way. Maybe everybody's updated. Does this talk about it? This also is subscribing, so this looks new as well. Okay, so that's good. So everyone that I've looked at, it looks like it's been updated, so that's good. The old way basically had no subscription. You can access the user ID immediately. Okay, so you got to be careful. Make sure you're using the updated ways. Make sure you're using new documentation. If it hasn't been updated since maybe end of 2019, beginning of 2020, let's say it's older than 2020. So either end of 2019 or beginning of 2020. Let's say it's older than 2020. Most likely it's outdated. Angular Fire, it's updating monthly. So you got to make sure you're using the new documentation. Otherwise, your code will not work. So you see I subscribe to the current user. Once I pull that back, I have the user information. Check to see if the user exists or not. Now here's how you connect to Firestore. This is what I want to show you. So I have this.db. Let's take a look at DB. That's an Angular Firestore document. So that's our database. So I pull the database and I'm looking at a collection called professors. And you'll see it has to be of type professor. We've defined this type. So if I come over here to the types, open up professor, professor will have an ID, a name, and when was it last updated. So if I come back, you'll see that's the type of professors. This is also asynchronous, so once this loads, I'm going to add a where clause. I'm going to do a tracked by whether the array contains the current user ID. So I'm going to have a professors collection, and each user that wants to follow that professor, I'll put their user ID in the collection, which is an array. You'll see value changes, so it's dynamic. Then I'm creating a pipe, which is like a socket. You can think of it like a socket. Now I'm going to map the professors. I'm going to sort them. When I have two professors, I'm going to sort them whether Professor A name is greater than Professor B. If it is, return true. Otherwise, return false. This code is complicated. This is what we call, what is this? What was that? RJX. This is RxJS. These are all RxJS commands. There's a good tutorial on RxJS. I recommend you go over because a lot of the Firebase commands are using RxJS. So if you search RxJS tutorial, they have a quick tutorial that you can go over that will get you up to speed in about 5 to 10 minutes. It's all about observables. That's why all this is a little bit complicated. Everything's subscriptions and function calls. Okay, I believe it's this one right here, learnrjx.io. They have a quick little tutorial you can go over, about 5-10 minutes. You'll be up to speed, and a lot of these calls will make more sense. But you got to realize Firebase and Firestore, especially Firebase, has no commands, but even Firestore is limited. MongoDB is also limited. It's not like a relational database. With a relational database, I can put as many where clauses as I want. I can do as much sorting as I want. Not with Firestore. Firestore is like MongoDB. I can only have some very basic where clauses. And a lot of this is happening on the front end. So I'm sorting here on the front end. I'm going to sort the professors' names alphabetically. So this is going to be in ascending order. And this is all happening on the front end. Let's take a look at get classes. So let's write some of our own code. That's kind of complicated because I'm doing sorting. Let's say I just want to pull data from Firebase. I don't care about the sorting. Let's see how easy this is. So get classes, I'm going to return. You'll see I'm returning an observable of class data. So I'm going to connect to the DB. I'm going to specify the collection. Collection is going to be in professors. Okay, and then I can grab a specific document. So I'm going to grab the document where the professor ID is equal to this. And then inside there, I'm going to have another collection. With MongoDB or with Firestore, I can have nested collections. You can see that in the console. So if I go back to Firestore, let's say I make a little test app. So let's say I start a collection. This is called test. Okay, I auto increment the ID. I have the field test, the value test. So here's my test collection. Here I can add a document. So you'll see that document's here. Now inside this document, I can start another collection, test 2. And I can have it nested. Test 2, test 2. Okay, so you'll see it can go nested here. So I have my first collection is test. In there I have a document with the document ID. Inside this document I can have fields. I can also have another collection. So if I click test 2, it starts all over. Here's another document. And I can start another collection. And it can be very nested. So that's why you'll see this here. I have a collection, then I have a document. Inside that document, I have another collection. So this is normal. You should see my database structure for problem solver. It's very nested. Let's see, is this in production or test mode? I'm in test mode. Production mode is locked down, meaning you cannot write to the database. You can only read. So make sure you're in the test mode. Okay, you'll see here's the next collection. I'm going to specify the type. I'm going to specify it as class data. I can also specify the first collection's type as professors. This collection is going to be called classes. And then I want to grab the value changes. So this is all you do. Basically, I just do the dot notation and call the predefined functions that are in the Angular Firestore package. Okay, these are predefined functions that are in the Firestore, and I don't even need to have it nested. I can have one collection and it has a bunch of documents. But if I want to do any type of sorting, for example, with MySQL, I could say do a join. I could say select star from professors, do an inner join or an outer join, whatever, with classes where the professor ID is equal. I could do that with MySQL. I could do that with a relational database. I could do joins. With MongoDB or Firestore, you cannot. So if you want to do a join, the way that you do it is have nested collections. So anytime I have my professors, anytime there's a class in there, these classes are going to be like joined tables. And then whenever the value changes, I also grab that information. So if I add a new class, this observable will also be updated. I recommend to use the type here as well. We have the professor type. Let's go ahead and use it. And that's how I can pull the classes. Let's say I want to get the professor details. Same type of thing. You got to understand the structure. But this one, we're not going to do anything nested. So I'll call the database. What collection do I want to use? I want to use my professor collection, which is of type professor. And then I want to grab the doc. The doc can also be of type professor. I may have messed this up. I may have messed the previous one up. I think you have to put the type professor on the doc. And then I'm going to grab the value changes. Let's see. So this is a collection, so you can't do type professor here. It's got to be on the doc. It's got to be on the doc. So I could put the type of document here. Yeah, I could put the type of document here. Let's just see if we can get this work. If this works, I'll come back and put the type professor up here. So remove that for now. Let's just see if we can get this to work, and I'll come back and put the type.
Is the type class data still fine?
Class data should be fine. Let me check out class data. Class data is this type here. It has all the information. Let me go back. Let's see, will this work? On my collection of classes, they should be of type class data. I think this will work because when we pull back value changes is going to be on each document in this collection. But let's run it. Let's see if this works. This should work. Okay, this should work. I also did this up here on this collection. I'm thinking it would probably work up here as well because they're all the same type. I have a collection of professors. All the professors' documents are of this type. Let's see if this works. Almost done. Let's finish up this add professor data. Okay, now this is a little bit different. Here we're doing gets. Okay, here we're doing gets. Getting data is easy. Go to the database, say what collection you want, say what document you want. Here, go to the database, say what collection you're in, say what document you want. Anytime the document updates, it will be modified. Anytime this collection updates, it will return the modified changes. What about adding data? Okay, this is a little bit more complicated. Now, this add professor data actually is going to connect to a cloud function. So maybe I can describe the workflow here. Let me draw this out. Okay, so you should see a whiteboard. Here's the structure. So I have my browser. Okay, I have my browser here. And then I have my Firebase Firestore. Okay, so here's my Firestore. I also inside, and the Firebase has a lot of packages here. So this big outer box is going to be Firebase. This is your Firebase API. Inside that, I have Firestore. Inside of this, I have a cloud function. Now, one thing with Firebase is you don't have a server running. You can host up on Firebase, so you'll have Firebase hosting. That's down here. You can host. You can have your Firestore. You can have your cloud function. You can have authentication. So authentication is also something in here. Okay, so they have all these little APIs. They don't have a server running. This is the new server. Cloud functions are the new server. And a lot of people are going to this. What's nice about a cloud function is you only pay for the time that the function is running. The pros and cons are you only pay for when the time's running. The con is that it takes a while for it to spin up. So this is our browser. This is our front end. It is our front end. Front end is going to make a request to add a professor. It's going to go over here to a cloud function. Cloud function is going to go and scrape the data. This is how I'm going to run Scrapey. So you want to run Scrapey or scraping the data. Here's my scraper. Scraper is going to go to the website, pull the data, come back. It's going to put the data into Firestore. Okay, it's going to put the data into Firestore, and then my front end is going to make a request to Firestore and then get the data back. This is the overall concept. So you don't really have a server. I can host the front end on the hosting service. I can use authentication. I can have a database. If I want to run back-end code like a scraper, I need to use a cloud function. Now, cloud functions are everywhere. They're on Amazon AWS. They're on the Google Cloud. They're on Microsoft Azure. Okay, cloud functions are definitely the way of the future. It's called serverless architecture. Firebase is a serverless architecture, meaning I have a database. It's independent from the hosting. It's independent from the authentication. You also have what's called, what's that called? It's called storage. Like if you want to upload files, you'd use Firebase storage. That's all independent of each other. And none of these have a server running. It's all on the file system. This database is also on a file system. It's stored in the database. So it's stored in the storage. Cloud function will put your code in the storage. Whenever it runs, it'll load it into memory. And whenever the code's done, it'll put it back into storage. Okay, so this is the structure of the website. Now, we need to look at the scraper before we can get this to run. Maybe we can, I don't know if we should write this code right now because we don't have the scraper running. Let's keep going here. Let's get the class details. We'll come back to the scraper. We'll look at the scraper next. I'm hoping to get this code to run. Get class details. Okay, get class details. If I want to, let's see, hopefully you can see my code. Hopefully you can see my code. If I want to connect to the database, again, I'm calling Firebase's built-in APIs. So let's say I want to get the class details. I'm going to go to the professors collection. I'm going to look for a specific document, which is the professor ID. And I'm going to go into the classes collection. And I want to look for a specific document as well with the class corresponding class ID. And I want to see if there's any changes to that collection as well. So here, I think the difference, what the confusion is earlier, is if you're grabbing just a collection, you'll put the type on the collection. If you're going all the way down to the document, then you need to put the type on the document. So here, I can put the type of the document here is professor, and the type of the document here would be class data. However, up here, I'm going all the way down to the doc, so I'll use the professor type. Up here, I'm only going to the collection. So that's why I can put the type on the collection. So it matters on how deep you're going. And we can look at this whenever we write the database structure, whenever this starts to go into the database. It all depends on how deep you're going. Each collection has documents. Each document will have a type. Each collection will also have a type based off of all the corresponding documents. So if you go down to the collection, put the type on the collection. If you go all the way down to the document, you can put the type on the document itself. Okay, it looks like we're done here. You can see how easy it is to get data. Adding data we already did on the login. It's, I think, 3 lines of code. Here's one line of code. Now this is written on several because this is prettier, but basically this is return and then one line of code, and I can pull the data. And what's nice is this is real-time data. It updates automatically. Let's start writing this out. It's not going to make sense until we get the scraper, but we can go ahead and write this out. So here, we're going to make a call to a cloud function. Now this is complicated. We're going to talk about cloud functions here in a second. So we need to create what's called a promise. A promise is basically like an asynchronous call. I want the cloud function to run, but I want to wait until the cloud function is done. If I return immediately, the cloud function will take some time to run. So it's going to be an asynchronous call. I'm going to have the resolve and the reject. This is what it requires for a promise. You have to have resolve and reject. That's what a promise requires. In this promise, we're going to make a call to a URL. Now the URL we're not going to have yet until we have the cloud function. And then I want to make sure the user is logged in. Okay, so I can do the authentication again. You'll see me check this everywhere. Okay, you'll see me check this everywhere, whether the user is logged in or not. So I'm going to do a then. Okay, and user will be passed. You'll notice I'm not writing all the code. Like when I click save, Prettier will pop in. It'll write some of those brackets for me, which is nice. So if the user is logged in, I want to make a call to this URL. And I'm going to use HTTP. I'm going to use HTTP, which was what we learned before. Here's how you do HTTP in Angular. So if the user is logged in, okay, I'm going to create another constant called data. And in order for my scraper to run, I need two things. I need the professor. What professor do you want to scrape? And then I need the user ID for who is the user that's scraping this data. So once I have this asynchronous call, I can get the UID easily. And I need to pass this data up to the scraper. So here's how I do an HTTP. If you want to make, a lot of students use APIs. They need to make an HTTP or HTTPS request to an API. Here's how you do it in Angular. I'm going to make a post request to, and I'm going to get this response back. Let's add professor data response. It just returns the number. An HTTP post requires a URL and the data. And I'm going to subscribe to this call. I'm only going to do anything when the result comes back. So here's my result. You notice when I save, Prettier kind of formats it for me, which is nice. So when the result comes back, what are we going to do? We had a promise there. I need to do a resolve and a reject. So if the result comes back, I'm going to call resolve, which means everything was added successfully. I'm using the backtick here. It's not a single quote. It's a backtick because I'm going to write variables in this string. So it's going to be added, and I can use a $sign to say this is a variable. From the result, I'm going to get back classes added. This is going to be returned from the scraper. How many classes were added? Okay, so I'm going to have a message for the user. And then I'm going to say how many classes were added for, and I'm going to say this dot prettier, and then the professor name. Okay, then this is a function call, the resolve, so you have a semicolon. I don't want to hit save yet so you can see it. So here's how you make a HTTP request in Angular. I'm doing a post. You could do get. The post will return some data, so I'm specifying the type on that return. I need a URL and data to be sent. URL's up here. We're going to set it in a second. Data is the data that I'm passing to this post request. I'm subscribing to it, which means I'm going to wait until it's done. Once I get the result back, I'll know how many classes were added for that professor and what's the professor's name. I already have professor's name here, but you'll notice I'm using professor name, which is the one that's passed here as a parameter. Classes added will be returned from the result. If I do save, you'll see prettier now. Change the code, the formatting. Sorry, I know that's a pain. To see, I can go do an undo if that's easier to see. So once the subscription's over, I have to do two things. I have to do a resolve and I have to do a reject. That's what's required for this promise. So here comes the reject. Okay, so I'm going to do a comma here on this subscription. On the reject, you'll probably get an error message. I'm not going to worry about it right now. So you'll see it's an empty parameter list. And so this is going to be what the reject looks like. I probably could get an error message if I wanted to display a particular error message. These are backticks, not single quotes. An error occurred. An error occurred while adding classes for, and now I can put a variable because I have those backticks. I'll say this dot prettier name, the professor name, so I can display it nicely for the user. And then I'll have a semicolon here for this reject. So that's, now I'm meeting the requirements for a promise. A promise is just like an asynchronous call. It's like an asynchronous call. I want to wait until this HTTP request comes back. I recommend you do that if you implement an API. Once the request comes back, I'm going to resolve the promise by telling the user how many classes was added, or I'm going to reject the promise and telling the user an error occurred. I don't want to hit save yet. Prettier is going to change the text, but I need to hit save eventually. And now we need this URL to work. Okay, so that's the next step, getting a cloud function to work.
One thing, don't you need an if user to make sure the user isn't null or like not logged in?
Probably actually. Yes, I probably should have an if here. Let's see. I'll probably do as long as the user exists, then go ahead and run this. That probably is wise to do. So let me put that if statement up there. Prettier is going to change it. Okay, I'm not going to click save yet. So let's see. This is the constant. And this is in the HTTP request. And then here's the end of the if. Okay, here's the end of the then to check whether the user is logged in or not. You can also do a catch here. You can say if they're not logged in, do a catch, or maybe if there's some exception that's thrown, you can do a catch. Here on the else, we can do an else here. If they're not logged in, maybe we do something like do another reject, which is on the promise. And we can say unable to authenticate. So I'm going to return back on this promise. I'm going to reject the promise. So if the user is logged in, make the HTTP request. Otherwise, reject, which will then return this promise. Okay, thank you, Ian. Good advice. Okay, I'm going to hit save. It's going to change this formatting here. Okay, I'm going to hit save. Let me know if I need to go back. Here's the new format. So if the user is logged in, create the data for the HTTP request. I'm doing a post to the corresponding URL. Once the result comes back, resolve the promise. If the result comes back, let's say the result does not come back, then reject, saying an error occurred. If they're not authenticated, also reject, saying unable to authenticate. Now, where does this scraper come in? I've added the scraper in the code. So it's called scraper.py. Let's take a look at it. Let's see if we can get this up on a cloud function for this to work. Okay, so if I do scraper.py, let's take a look. Now, I was using Scrapey before. Doesn't mean you have to use Scrapey. You can use Beautiful Soup. There's some JavaScript ones. I see a lot of students like the JavaScript scrapers. For this one, I'm going to use Beautiful Soup. Okay, you'll see this is a Python script. I'm using Firebase credentials to get to Firestore. You got to create a service key. We're going to do that here in a second. I'm going to that music. I call it music. I guess it's really not music. I'm going to Music 1, Missouri.edu to grab the distribution, and I'm going to scrape it. So here I'm going to make sure that I allow all requests to this cloud function. So you see I have a header. I'm allowing the origin to be star. I'm also returning JSON. I'm returning JSON. So you'll see if it's not equal to post, go ahead and return. It's got to be post, and it's got to have request body. So I need to have professor in the request body and user ID in the request body. If they are, go ahead and connect to Firebase. Now, all this code that I pulled is right from the docs. So if I go to Firebase's docs for Python, Firebase for Python, they have docs here as well. So I grabbed all this from the docs. That's what I like about Firebase. You can connect to it in any language or almost any language. So it's the same. Connect to Firestore. You'll see I'm doing a collection called professors. I'm going to see if the professor's already there. If they exist, okay, I may do an update. I may update the array. If it doesn't exist, I'm going to go ahead and create a document for that professor. You'll see I get the professor ID, set the corresponding information. I'm going to do a scrape. I'm going to do a post to that URL. Beautiful Soup will grab the raw HTML. You'll see I'm going to go through the table. I'm going to grab all the information. I'm going to loop through till there's no more, grab all the information. You'll see I have a counter. If it's successful, I'm going to return how many classes were added with the counter. Otherwise, I'm going to return a bad request. Okay, so just a really quick scraper. I need to put this in a cloud function. How do I do that? Well, if I come over here to Firebase and I go over here to the cloud functions, okay, I'm not sure what yours says here. Yours may need to say get started. Yours may need to say get started, but you'll see, I guess you won't see it here. Let me try to do a quick search. Firebase cloud functions. Okay, Firebase cloud functions. If I go to Firebase's cloud functions, you'll see I only have two types. I can do JavaScript or TypeScript. That was the only types I can do in Firebase. That's a problem. I want to run Python. Well, what's nice about Firebase is it's connected to the Google Cloud Platform. So for example, I have my Firebase app created. Let's say I come over here to the Google Cloud Store. So if I go over here to the Google Cloud, I'm not sure why I said store. I guess I should have said services. If I go over here to Google Cloud Services, you can log in with the same information as you did your Firebase console. Go over here to the Google Cloud Console, and what's nice about it is you can connect to Firebase. And what's nice about it is the cloud functions have more languages. So everything you can do in Firebase is also connected to the Google Cloud. In fact, Firebase is a subcomponent of Google Cloud. Firebase is a subcomponent of the Google Cloud. So if I click on projects up here at the top, you should see a bunch of projects here. If you don't see yours, I clicked right up here on the top left. If you don't see yours, you can always type. So if I do grade distribution, you should be able to see grade distribution app fall 20. Now this was created in Firebase, but I can access it from Google Cloud. So if I select it here, okay, if I select it, you'll see all the functionality I have in Google Cloud. Now, one thing you want to be careful is, if I scroll down, they have Firestore. Now, let's see, that says File Store. I think they have Firestore as well. Here's Firestore. Databases, they have Firestore. Be careful here. You do not want to use Google Cloud's Firestore. You still want to use this Firebase's Firestore. But if I click it here, you'll actually be able to see your data. This is the data that is in Firebase's Firestore. It's in Firebase's Firestore. They're actually connected. They're actually connected. But I had some problems with my scraper when I tried to put it in the cloud, Google Cloud's Firestore. I didn't always see it in Firebase's Firestore. So you'll notice in my scraper, I use Firestore, not Google Cloud Firestore. Look at the imports here. They're different. You could use Google.Cloud Firestore, but instead I'm using Firebase's Firestore. Be careful there. Be careful there. Okay, there's a difference. That's why I left this comment in here. You may use Google Cloud's Firestore and it works just fine. When I did this a few months ago, it did not work. Firebase's Firestore goes into Google Cloud. It's not necessarily the other way around. So just be careful there. Make sure you use Firebase's. But I'm going to use over here what's called a cloud function. This is basically your server now. It's a serverless architecture. And if you want to run server code, you'll put it on a cloud function. So if I click cloud functions here, you may get some message. It may tell you that if you want to use a cloud function, you have to enable billing. I believe I got that message at the beginning. I believe if you wanted to use a cloud function, even in Firestore, you'd have to enable billing. Okay, you'd have to enable billing. So I clicked enable billing, and then I had just a default account. I believe you have to put that in when you create your Google account anyway. So I say enable billing, and then I select the default account. But when I go to create a function over here, so if I do create a function, look at this. I can put a function name. Okay, doesn't matter. Let's say I call it get professor data. It looks like I already have that, so I'm going to put get professor data fall 20. We're running out of time, so I'm going quickly here. You'll see authentication. Manage authorized users with Cloud IAM or allow unauthenticated invocations, which is a public API. So I want this to be a public API. Basically, anytime you make a request to this URL, the cloud function will go and scrape the data. You'll see I can pick the region. It's recommended US Central, which I will select. Go ahead and click Save. But what's nice about here is the code can now be written in several languages. It can be written in Go. It can be written in Python. And you can see that here. What's the runtime? I can do .NET, Go, Java, Node, Python. Okay, so I have a lot of different options here as compared to Firebase's cloud functions. Some students got a scraper working in JavaScript or TypeScript. If you write JavaScript or TypeScript, go ahead and put it in the cloud functions over here. If you need Python or other languages, put it in the Google Cloud platform. So I'm going to click Python 3.7 or it could be 3.8. I'm going to take the scraper code that I provided for you, basically copy all of it. I'm going to paste it here in the code section. Okay, basically this is our scraper. Now this took me some time to write. I didn't just have this scraper ready to go. It took me some time to write. You know, I had to go to the web page just like we did before and then go and see what HTML to do. So if I do an inspect, I had to do that procedure as well. Grab the corresponding table data, grab the IDs, grab each individual data, and I had to scrape all this data. So I had to study the web page, find out how to scrape it. But once you get that done, go over here and put it in the Google Cloud function if you have to write Python, which is what we learned in class. And this is basically all ready to go. You'll see it creates a collection called classes. Okay, it inserts. You'll see I have a class doc, create a document, and then I do a set. So whenever I have all the object data, I'll do a set, and that's going to insert the data. Okay, it's going to insert the data. The only thing you need here, which we're running out of time, I'll probably keep recording, is you need a service file. You need a service file. Okay, we're going to talk about that after I get this attendance collected. So let me collect the attendance. Okay, let me collect the attendance. Go ahead and put your name and pop in on the chat. Keep building the final project. Try to use tools like this. Okay, try to use tools like this. We had an hour, and I'm already connecting to the database. And here in a second, I'm going to start inserting data into the database. Okay, but I'm able to do that within 1 hours of time because we're using all these tools. So make sure you're using these tools. Okay, make sure you're using these tools. And we're out of time, so put your name and pop it in the chat. I'm going to keep recording here for maybe 5 more minutes. So if you have to go ahead and leave. Otherwise, let's finish this up and let's see if we can get this scraper to work. I have maybe 5 or 10 more minutes, and this should be done. And we're able to pull data from Firestore, also insert data into Firestore. Okay, you got to go, leave. Otherwise, I'm going to keep going. So here's Python 3. You'll see it says the entry point should actually be this update function. Whenever this code runs, you'll see I don't really have a server. This is a cloud function. This code will be stored on the file system. Whenever I make a request to it, it's going to be loaded into memory. It's going to execute, do what it needs to do, and then it's going to be put back into the storage. And you only pay for the runtime. So whenever the code runs, you pay for that. Whenever the code's just sitting there and idle, you don't have to pay for that. It's free because it's going to put it back into storage. So the entry point when this code runs is going to be the update function. So make sure you put update up here. And you'll see I put a note here, requirements.txt should have these. So I'm not on a server. How do I do imports? For example, I'm importing Beautiful Soup. I'm also importing Firebase admin. On a server, I do an npm install. I would do some of the other ones like Python. I do pip install Beautiful Soup. I don't have that here. But I do have requirements.txt. And what will happen is every time this code runs, it's going to go ahead and install the corresponding packages. So in requirements.txt, you need to put the package. You also need to put the version. If you don't put a version, it'll default to the current version. So here, you'll see I put Beautiful Soup 4.6, and then I just do Firebase admin. I didn't put a version here, so it's just going to default the version, okay, to whatever the most current version is. So I have the requirements text. This is how you do imports. So basically, this is going to do like a pip install Beautiful Soup 4.6. This is going to do a pip install Firebase admin, just like we did on our servers. Back in main.py, the only other requirement is I need this JSON file here, which is a service file. I need to connect this Python script to my Firebase. To do that, go back to your Firebase account. You'll go to your settings. I go to project settings. You'll see I have a service account here. And you'll see on this app, I can select service account. So if I do Python, you'll see I'm following what they tell me to do. Import Firebase admin. From Firebase admin, import credentials. From the credentials, have a JSON certificate. You see it says service account key.json. And then go ahead and initialize the Firebase app. So it tells you in Java, this is how you do it. In Go, this is how you do it. In Node.js, this is how you would do it. And in Python, you need to follow this. So if I go back to my Python code, you see I do have import Firebase admin, and I do have import credentials. And I have the two following lines is what it's asked me to do. What I don't have is this service account key. So it says generate new private key. So if I generate new private key, you say your private key gives access to your project's Firebase services. Keep it confidential and never store it in a public repository. Store this file securely because your new key can't be recovered if lost. Okay, I can also do it over here. So if I go to the Google Cloud Platform, if I go over to the Google Cloud Platform, I can create one over here as well. So you see it goes to service accounts. And then it should say Firebase admin. Now I've generated a key. But if you've not generated a key, it'll say no keys here. on the first time that you create this. So I'm going to come back over here to Firebase. I'm going to generate a new private key. I'm going to do generate, download it. Make sure you put it in a good place. Okay, make sure you put it in a good place. I'm just going to put it in my 4830 directory for now. And you'll see this JSON file. So if I open it up, it has all the private information. Okay, it has all my private information. So if I open it up, basically whatever's in this file, I'm going to copy it and I'm going to put it in my scraper. So once you generate a new private key, back on the Google Cloud, if you were to refresh this, it should say that you've now generated a key. Okay, it should say now that you've generated a key. So you see I have 2 keys now actually, because I generated one earlier. Back in the Cloud function, now you literally copy and paste your JSON file here. So I'll take that string out, paste my JSON file. Doesn't look the prettiest. Go ahead and add that information here. Okay, you'll see it has all the information like what admin are we using, what service account, what token, what project ID. Once I have this set up, you can go ahead and deploy this Cloud function. So I'm going to click on deploy. I updated main, I updated requirements.txt, and I updated the Firebase key. So I updated the key as well. Okay, it may take some time to deploy. Hopefully it goes through. It looks like my last deploy did not work. But once this is ready, you basically have server-side code. This is how you write your server-side code. Any server-side code that you need besides connecting to the database should be here. Okay, so you'll see I can do a testing. And in the source code, I tell you how to do a test. So here's a test example. You got to put what professor you want, and you got to put what user ID is requesting the data. So if I copy this, put it in the test, it says function is still being deployed. I already know the professor's name because I've grabbed that from the website. What we do need is the user ID. Where is this going to? If I go back to my Firebase, go into the Firestore, you'll see which users I have. So here's my user. Let's say I want to do it in test 4. I'll grab this user ID and I'll put it here in the test. Okay, I'll put it here in the test. Now this is still running, but once it's deployed, I should be able to run this. It's going to go scrape the data for this following professor, and then it's going to put it, looks like it worked. Function is active. That's what we like to see. So now I can test the function. So if I go back here to the database, you'll see all I have is users. I don't have any data yet to display. And we're going to do this on test 4. So on test 4, we're going to look for Professor Wergeles. So I do test the function. Let's see if it runs. So again, this Cloud function is stored into the storage. Whenever you run it, it's going to go to the storage, put it into the memory. Look at it, added 25 classes. That's what I like to see. It puts it into the memory, runs the code. Once it's done running the code, it puts it back into the storage like in a hard drive, and you only pay for the time that it took to run. So it added 25 classes. Let's see what happened into my Firebase. So I do a refresh. You'll see test 4 is here. I should see a professor's collection. It should be in real time. So, okay, so here's professors. It's here. You'll see I have classes for Professor Wergeles. And here's all the classes that it pulled. It pulled the A's, the B's, the C's, the D's, the F's. It pulled the department. It pulled the average GPA. It pulled the instructor, the course number, the section, the term, the title, and all the various information. Now, if I go back to that user in test 4, you'll see the user ID is this. So if I go to professors, for each professor, you'll see it's being tracked by this user. So test 4 is tracking Professor Worgles. That way I don't store the data multiple times. If I want test 3 to track Professor Worgles, I wouldn't scrape Professor Worgles again. I would just say, okay, add test 3 to this professor. That way I don't have duplicated data. So now, how do I run this scraper from the front end? Well, you'll see it's testing, function executed, log files look good. You'll see here's the trigger. The trigger has this URL. So if I copy the URL, and if I send a post request to this URL, it will run. So in my data service file, we just wrote the code, put the URL as the scraper we just uploaded. Okay, put the URL as the scraper we just uploaded. For testing purposes, you can use this URL, but I'm going to take it down here a little bit so I don't have to pay for all these requests. So just run it once, and then I'm going to erase this cloud function because I don't want to have to pay for all those scrapes. But let's see if this will run. Okay, let's see if this will run. Let's see if this works. So I'm going to go back to see if I can run this code, and then we'll be done for today. So it compiled successfully. I'm going to go ahead and do an ng-serve again just to be sure. I'm going to go ahead and do an ng-serve again just to be sure, and let's see what the page looks like. Hopefully we can actually run it this time. So we had to write a lot of code. Let's see if we can run it this time. We want to start on the login. And wait till you see my login. It looks good now. I added the proper imports. Now you can use this login on your final project. Definitely use any of this code that we're writing. I want you to use this code so you can get your final project done quickly. So if you want to use this login, the front end, the back end, please do so. Okay, it's building. Give it a second. Okay, it's building. Give it a second. This is a really awesome project. I really like. This is a perfect example for a final project, for an undergraduate final project. I have a scraper. I'm pulling data. I connect to Firebase. I have a login. I'm going to use Firebase hosting, so it's going to be on HTTPS. The data is persistent. It's secure. The pages look good because I'm using Angular material. Okay, I did a URL hack. You see I go right to the home page. I need to do auth guards. We're going to do that here in a second. Here's my new login. Look at this. I like this. So let's say I do a register. I'm going to register Professor Worgles. I think I had test 4. I'm going to do test 5 now at test5.com. Password is PASS, pass. Register. You'll see it goes to the home page. If I go back to Firebase, look at my users. Here's test 5. So test 5 is available. Right now, test 5 is not observing any professors. And you'll see I need to add my nav bar. We haven't done that yet either. I'm not observing any professors. So if I click add, here is my add professor portal. This is the one that I've created myself that I wanted to pop up. Looks like we need to add some code to this. Okay, looks like we need to add some code to this pop-up. But essentially, you would search Worgles, you click the professor, click go. It would go and run the scraper. Scraper would run the data, see if it's there, scrape it. If it already scraped, it would just add the user to that professor. If it hadn't, it would go ahead and scrape the data, pull all the courses down, and then it will actually display all the courses here to the user. Let's see, just a few lines of code. I know we're going way over here. If you got to leave, go ahead and leave. I just want this video to be done so students can use this for their final project. Let's fix up this add professor component. Okay, I think we just got a few more lines left. In add professor component, you'll see I have choices and I have filtered choices. One bad thing about Firebase or even MongoDB, it's really hard to filter data. It's really hard to sort data. So a lot of the sorting is going to happen on the front end. And remember, for your final project, your project must have some data in it by default. Don't have an app where the TA is loaded and there's no data there. There should be some default data. So guess what I'm doing? I have a JSON file with some default data, professor names. Instead of scraping the professor names each time, I'm going to have them preloaded in a JSON file. Okay, so I'm importing the JSON file. If you want to import JSON, remember you have to go and change the TypeScript configuration. You're going to add these 2 lines of code, otherwise that import will fail. You basically have to tell the TypeScript you want to be able to import JSON. Once you do that, okay, you'll see I can add this import here. And I'm going to import professor. So here, once the page loads, all the choices are going to be from that JSON file. So I'm going to say professors dot names. Now, where's this coming from? If I open up my assets directory, I have a JSON file with all the professor names. So I open this up. You see it's nicely formatted. Here's the names of all the professors. I scraped this. My scraper actually pulled this down. So if I search for Wergeles, you'll see Wergeles is here. Now, it can only allow so many characters, so it cut off my middle name. But I'm there, and all these choices are there. Now, on the original site, it was horrible. Do you remember how long that drop down was? So I don't really want to show all the names, at least at the beginning. So I'm going to filter some of them so it's easier to view and easier to use. So I'm going to grab the original choices, and they have a slice. I'm basically going to take the first 100. That way the list isn't so long. And then they can search. So if they search, what am I going to do? Okay, I'm going to have a constant variable here. I'm going to have a constant. I'm going to have a search value upper. Okay, so basically I'm going to grab the search value because you'll see all the names were uppercase. Not only in the JSON file, you'll see all the names are uppercase, but also in the API, also in this website that I'm scraping. If I select a professor, the names are also all uppercase. So I want to make sure the user doesn't enter in any bad data, because if they enter in lowercase, it's not going to find it. So I'm going to take whatever they typed and make sure I do a 2 uppercase. Okay, and use the built-in functions. Don't write these functions yourself. And I'm going to take the filtered choices, and I'm going to set that equal to the choices, the full choices. So I have the full choices, and I have the filtered choices. The full choices are all the professors. The filtered choices are what the user is going to see. So from the original choices, I'm going to filter them, and I'm going to look at each professor. Okay, I'm going to look at each professor, and I'm going to return each professor in an uppercase form that includes, they have an includes function that includes whatever the search value is, and make sure that's the uppercase one. Okay, once this is done, I also don't want to show all of them. Remember, if I show all of them, that list is huge. So I'm also going to slice this. I'm only going to show the first 100 filtered choices. Okay, I'm only going to show the first 100 filtered choices. And what happens if they select a professor? If they select a professor, I'm going to call that HTTP request and go and scrape the data. So I'm going to do a try and catch. We may not need this at first. Let's just try. So I'm going to say is loading is equal to true. That's going to pop up a little loader. And then I'm going to call my data service. I'm going to call the add professor data with the professor name. Professor name is from the one in the list, so it's already uppercase. Can I call the then? Okay, I can call the then. So if this works, okay, if this works, maybe I'll do a console log, and maybe I'll do some type of success message. So the result should have a success message there. We can console log the result. Then once it's done, I'll put is loading equal to false, which will take down my little loader. I'll have a snack bar. Okay, this is Angular material. I'm going to do a snack bar. I'm going to open it up. And I'm going to pass in the result, which should be the success message. And actually, I can change this to success message. Okay, to success message. That way we know what it really is. And that message is actually coming back from the HTTP request. So if I go back to data service, you'll see it's either going to put added this or rejected this. Those are the messages that are going to be printed out. So those are the success message that I'm talking about here. And then I'm going to put the duration of how long I'm going to show this snack bar. So I'm going to show it for 5,000 milliseconds, which comes out to be 5 seconds. And then once it's done, I'm going to close the mat dialog, which is what they see to select the professor. And then if anything goes wrong, do a catch, and this will be your error message. This is going to be that promise. So either I'm going to have a success message which says added, or I'm going to reject the promise, and I'm going to have an error message. So if there's an error message, what am I going to do? Okay, if there's an error message, I'm going to go ahead and log it just to see what's happening. So I'm going to go ahead and log the error message. And then I'm going to say the is loading is also false. Bring down that loader. I have a little twisty menu loader. And I'm going to have the snack bar display the error message. And I'm also going to display this for 5 seconds. Okay, this is going to be pretty awesome. So once they search, I'm not going to show all of them, just show the first 100. Once they select the professor, I'm literally going to go and call that scraper. I'm going to call this scraper and try to scrape the data. Okay, the scraper is going to run. If I've scraped data already, I'll go back over the scraper code. But essentially, if I scraped data already, do an update. If I haven't scraped, do an insert. When I do an insert, make sure you add the user that's trying to scrape the data. And that way, we don't have to store multiple professors. We store one professor, and we keep track of all the users who want to track that professor. It's almost like on Facebook or LinkedIn or any of the social media when you follow somebody. So instead of storing each person's information whenever you follow them, you just keep track of that user once, and then you keep track of how many people are following that user. That way you don't have to store the data multiple times. Let's see if this runs. I'm curious. I hope it works. So let me go back into the login. We've already created login 5, test user 5. So let me log in. We'll add the auth guard here in a little bit. That way you can't URL hack. Okay, so I'm logging in. I'm not observing any professors yet. So if I click on add, here's the first 100. Look how much nicer this is compared to the real site. So I'll type in Wergeles. Here I am. If you click it, you'll see my loading icon. Error occurred while adding classes. Okay, so we have a problem here. But here's the search bar, and here's the information. So if I type in W, shows the first 100. WER shows the first 100. Okay, type in G. Once I get to G, there's only one Wergeles. So that's the only one that displays. So I click on it. Okay, if I click on it, it should try to run the scraper. It did, but you'll see an error occurred. So I can click on cancel. Let's see. Let me log in as test 3. Maybe test 3 has Professor Wergeles there since we scraped it manually. Was it test 3 or test 4? I can't remember. Let me try test 4. Test4.com, pass. Okay, it wasn't test 4. So let me go back. Let me log in as test 3. This one doesn't have one either. I was hoping one of these would have it. Let me go back to my Firebase. Okay, I have professors here. I have Professor Worgley's. Oh, 2 people are following him. Looks like the scraper did run. Looks like the scraper did run. I don't think I ran the scraper twice, did I? On manually. So let's see. Here's test 3. Let's see here. What's this? Test 5 is there. And what's this other one? ENY. ENY. And test 4 there. So let me try to run it on test 3 from the UI, and let's see if it gets added. So I'm going to log in as test 3. You saw only 2 users were there, and I'm not running this manually. I'm logging in as test 3. Go to type Worgles, click add. I had an error occur, but let's go back to Firebase. Are there 3 users under this professor now? There are. So it's adding them. It is working. Let's try to scrape a new professor. Let's try to scrape a new professor. Any professor in mind? Let's try to scrape Dale. I'll try to scrape Dale. Let's scrape Dale. You'll see it takes a while. It's an asynchronous call, so it waits until the scraper is done. And there may have been an error because we scraped that professor already. So it's scraping Dale. It's going, it's running that HTTP request. Look at that. Added 105 classes for Dale. If I come back to Firebase, you'll see I have 2 professors now. I have Worgles and I have Dale. And the scraper did work, and it put test user 3. So I must be getting an error message because there's no data to scrape. I didn't add any courses, but it's working. What's not working, though, is I'm wondering why the professors are not showing up on the dashboard. Okay, that's something that we need to look into. For some reason, professors are not showing up on the dashboard. Let's see, we did get the professors at the beginning. Okay, we did get the professors at the beginning. Let me go back to my data service. Those professors should be showing up. So this scraper is working. There's get class details. Let's see if I can get, let me see, what was that? It says get professors. So let me go to get professors. Here's get professors. Let me check this real quick. So if they're logged in, check the user, then return the collection professors. Make sure that the user is in the array. So make sure the user is tracking it. If the user is not tracking that professor, it will not show up. So I have a where clause there. The user that's logged in needs to be in this tracked by array. Their UID does. And when the values change, update it, I'm also going to sort the professors. So let me put an else here. Maybe this line of code is not working. So let me do a console log. User not logged in. Maybe that's why it's not showing up. Let's try to go back to the home page. If that's why it's not showing up, I may need a little bit of time to look into it. User not logged in. So that's the reason they're not showing up. It should be logged in, so I may need to look into this. But overall, the scraper is working. We are getting into Firestore. User not logged in. Let me try this again. User not logged in. Let me go back to the login page. Okay, so let me try this again. So maybe our authentication code is not working correctly. Let's see what it prints out. It didn't print out users not logged in. An error occurred. I mean, I need to look at this. But it should have the professors here and then displayed on the home page. You can click on a professor, and then we'll go and draw some graphs here in a little bit. So at least the scraper is working. At least you can see how to get data from the database. I believe the data is here. I believe the problem here is this user ID. Maybe this user ID is not being polled. So we need to look and see why we're not able to get the professors. But I'll have to do that here in a little bit. Okay, that's all for this lecture. Thank you all for staying.